What if I told you that the concept of robots isn't as modern as you think? The desire to create artificial beings that can perform tasks for us is deeply rooted in human history. Long before the advent of electricity or computers, our ancestors imagined mechanical helpers and mythical beings capable of performing superhuman feats. These early visions laid the groundwork for the robots we know today. They reflect our enduring fascination with creating artificial life. The ancient Greeks, for instance, told tales of Hephaestus, the god of the forge, who created mechanical servants to assist him in his workshop. These mythical beings, often depicted as bronze giants imbued with intelligence and strength, served as early prototypes for the robots that would capture our imaginations centuries later. These stories highlighted the desire for artificial helpers, capable of easing our burdens and performing dangerous or repetitive tasks. From ancient mythology to early scientific thought, the concept of artificial beings has persisted throughout history. These early imaginings, though often rooted in fantasy, reflected a fundamental human aspiration to create artificial beings that could extend our capabilities and reshape our world. As we delve deeper into the workings of the natural world, our dreams of artificial helpers began to take on more concrete forms. The desire to create artificial life, once confined to the realm of myth and speculation, began to take root in the minds of inventors and dreamers. The stage was set for the emergence of the first robots. A robot is more than just a machine. It is a creation that embodies our ingenuity and our desire to extend our reach beyond the limits of our own bodies. At its core, a robot is a machine designed to perform tasks automatically, but it is the element of autonomy that truly sets a robot apart from a simple tool. Robots are equipped with sensors that allow them to perceive their surroundings, actuators that enable them to interact with the physical world, and a control system, often in the form of a computer program that guides their actions. This combination of sensing, action, and intelligence is what gives robots their unique ability to perform tasks that would be difficult, dangerous, or impossible for humans to carry out. The word robot itself is derived from the Czech word robota, meaning forced labor. This etymology reflects the early perception of robots as tireless workers, designed to take on tasks that humans found undesirable. However, as robot technology has advanced, so too has our understanding of their potential. Robots are no longer limited to the role of simple automatons. They are becoming increasingly sophisticated, capable of learning, adapting, and even making decisions on their own. This evolution has blurred the lines between machine and something more, raising profound questions about the nature of intelligence and the future of our relationship with technology. The path from mythical beings to real-world robots was paved with centuries of innovation in mechanics and engineering. Long before the advent of the digital computer, inventors and tinkerers were fascinated by the idea of creating machines that could mimic the movements and actions of living beings. These early automata, while often simple by today's standards, laid the groundwork for the development of more sophisticated robots. One of the most famous examples of early automata is Leonardo da Vinci's mechanical knight, designed in the late 15th century. This intricate creation, though never built in da Vinci's lifetime, was designed to move its arms, legs, and head, and even to sit and stand. The knight's movements were controlled by a system of pulleys, cables, and gears, demonstrating a remarkable understanding of mechanics for the time. Da Vinci's work was not an isolated example. The 18th century witnessed a flourishing of automata, with skilled artisans creating intricate clockwork mechanisms that could perform a wide range of tasks. These creations, often displayed in the courts of European royalty, captured the public imagination and spurred further innovation in the field of mechanical engineering. One notable example was the digesting duck, created by Jacques de Vaucanson in 1739. This mechanical marvel could flap its wings, eat grain, and even excrete a simulated digestive product. While the duck's digestive process was ultimately an illusion, it showcased the potential of automata to mimic complex biological processes. These early automata, though often little more than curiosities, represented a significant step forward in the development of robotics. They demonstrated that it was possible to create machines that could perform complex actions, paving the way for the development of more practical and sophisticated robots. Section 4. The birth of the industrial age robot Unimate. The mid-20th century marked a turning point in the history of robotics with the advent of the first industrial robot Unimate. In 1954, George Devil, an inventor with a vision for automating industrial tasks, filed a patent for a programmed article transfer, a device that would revolutionize manufacturing. Devill's invention, later dubbed Unimate, would go on to become the first commercially successful industrial robot. Unimate was a hydraulic arm controlled by a computer program stored on a magnetic drum. It could perform a variety of tasks such as welding, painting, and assembling parts with remarkable precision and speed. In 1961, General Motors installed the first Unimate robot in its New Jersey plant, where it was used to extract die-cast parts from machines and weld them onto car bodies. This marked a watershed moment in the history of automation, as robots began to take on tasks that were once considered too dangerous or repetitive for human workers. Unimate's success paved the way for this widespread adoption of industrial robots in factories around the world. The impact of this new technology was profound, transforming the nature of manufacturing and ushering in a new era of automation. The development of Unimate was not solely the work of George Devil. Joseph Engelberger, an engineer and entrepreneur, recognized the immense potential of Devill's invention and played a crucial role in bringing it to market. Engelberger founded Unimation Inc., the first company dedicated to manufacturing and selling industrial robots. Together, Devil and Engelberger laid the foundation for the modern robotics industry, their work paving the way for a future where robots would become essential tools in a wide range of industries. Section 5. Beyond the factory floor, humanoid robots take center stage. While industrial robots were transforming factories, a new breed of robot was capturing the public imagination: the humanoid robot. These robots, designed to resemble humans in form and function, represented a significant departure from the purely functional designs of their industrial counterparts. Humanoid robots held the promise of interacting with the world in ways that were more intuitive and engaging for humans, paving the way for their use in a wider range of applications. One of the most iconic early examples of a humanoid robot was Asimo, developed by Honda Motor Company. Asimo, which stands for Advanced Step in Innovative Mobility, was first unveiled in 2000. This remarkable robot was capable of walking, running, climbing stairs, and even dancing, all while maintaining its balance and navigating obstacles in its environment. Asimo's advanced capabilities were made possible by a combination of cutting-edge robotics, including sophisticated sensors, actuators, and control systems. Its development represented a major milestone in humanoid robotics, demonstrating the potential for robots to interact with the world in ways that were once thought to be the exclusive domain of humans. Another notable humanoid robot is Sophia, developed by Hanson Robotics. Sophia, activated in 2015, is known for her human-like appearance and her ability to hold conversations, recognize faces, and even express emotions. While Sophia's capabilities are still under development, she represents a significant step towards creating robots that can interact with humans on a more social and emotional level. The development of humanoid robots like Asimo and Sophia has pushed the boundaries of robotics, demonstrating the potential for robots to go beyond simple industrial tasks and play a more active role in our daily lives. These robots have captured the public imagination, sparking both excitement and debate about the future of human-robot interaction.